Alright guys, now we have lesson 5-6, and it's going to be about parallel and perpendicular lines. So the objectives here, we want to determine whether lines are parallel, perpendicular, or neither. And these aren't all going to be from a graph. Obviously parallel lines, you know what those look like, and probably perpendicular, but we're going to determine them based on the equations. And then we're going to be able to write equations of parallel and perpendicular lines. Okay, so here's our vocabulary. Parallel lines, they never intersect. So you should know that, like two lines like this, they would be parallel. Two lines like this, they would be parallel. But this is what's really important for us right now. They have the same slope. So if we have a graph, and I have one graph that maybe starts at the origin, is going up 2 over 1, up 2 over 1, up 2 over 1. The slope is 2. If I have another graph that starts down here at -3 and it's going up 2 over 1, up 2 over 1, up 2 over 1, those are going to be parallel. So parallel lines have the exact same slope. Now perpendicular lines, they intersect to form right angles. So those two lines right there are perpendicular. Those two lines right there are perpendicular. Their slopes are going to be called opposite reciprocals. And opposite reciprocals is probably a new word, so it's best if I just show you some examples. If you have something like 1/3, okay, the reciprocal of 1/3 is you just flip it upside down, so it's going to become 1 over 3. But opposite means we need to make it negative. So if it was positive, it becomes negative. So 1/3 and -3 over 1 are opposite reciprocals. Something like -2 over 5, the opposite reciprocal, flip the fraction upside down, make it 5 over 2, and because it started out as negative, the opposite of a negative is a positive. And then if I have just a regular number, the reciprocal of a regular number, now think, 5 would be 5 over 1. So the reciprocal is 1 over 5, and because it started out negative, it's going to become positive. Okay, so that's what opposite reciprocals are called. Sometimes they're referred to as negative reciprocals, but it's the exact same thing. It really just depends what book you're getting it from. And our book uses opposite reciprocals, so that's usually what I say. Okay, there's a couple special cases. So vertical lines are always parallel to other vertical lines. Like what we just talked about was if they're parallel or perpendicular is completely dependent on the slopes. Well, vertical lines going up and down like this, remember their equations are like x equals 3 and x equals 5. So the slope of a vertical line, the slope would be undefined. It's actually not even a function because it fails the vertical line test. But when we start looking at numbers, two numbers that are the same, like the example I showed you, a slope of 2 is parallel to another slope of 2. But vertical lines, you don't necessarily see the slope in the equation, but vertical lines are going to be parallel to other vertical lines. Same thing with horizontal lines. They're going to be parallel to other horizontal lines. They have the equation like y equals something, y equals 5, y equals 3. Now horizontal lines have a slope of 0. So they would have the same slope, but they're not going to be written in slope-intercept form. And then anytime you have a vertical line and a horizontal line, they're always going to be perpendicular. So if you have a slope that's undefined and a slope that's 0, even though they're not necessarily opposite reciprocals, because you can't do the reciprocal of 0 and you can't do the reciprocal of something undefined, that's a special case, and those are still going to be perpendicular. Okay, so here's what we do, writing an equation of parallel lines. So it gives us this information. We have a line that passes through this point, 12, 5, and is parallel to the graph of y equals 3 over 2x minus 1. What's the equation of the line in slope-intercept form? So we have one equation. We have this equation. But we want to write a different equation that goes through 12, 5. See, this equation probably doesn't go through 12, 5, but wherever 12, 5 is located, 12, 5, somewhere right here, this line is going to be parallel to that. Okay, so think about it. if they're parallel, we know the slopes are the same. So we're trying to write an equation that has a slope of 2 over 3, because we get that right from the other equation because it says they're parallel, and it goes through the point 12, 5. So if we're given a slope and a point, the best formula to use would be point slope. So y minus y1 equals m x minus x1. Okay, so we're going to do y minus our y value, which is 5, equals 2/3 x minus our x value, which is 12. Now be very careful because it says what's the equation of the line in slope-intercept form. So we have to write this equation in slope-intercept form. So we're going to distribute here. So we still have y minus 5. 2/3 times x is 2/3 x. 2/3 times 12. Now if I do that over here on the side, 2/3 times 12, I know that 12 divided by 3, if you look diagonal, 12 divided by 3 would be 4. So it's really just 2 times 4, which would be minus 8. And then add 5 to both sides. Make sure you add it on to the number, not the x part. So we have y equals 2/3 x, and negative 8 plus 5 would be negative 3. So we have two equations, y equals 2/3 x minus 1, y equals 2/3 x minus 3. If you do it right, the slope should still be the same because they're parallel, but you just have different y-intercepts because one's going to be down here. I actually drew that pretty good. This is going to go through down here at negative 3, where this one is going to go through, maybe more like down here, through negative 1. And they're going to be parallel. Okay, so let's do another one of those. We have a line that passes through this point, negative 3, negative 1, and is parallel to this equation. So, you don't have to graph these points, but sometimes it helps. If we come to negative 3, negative 1, that's right here. So we're writing some equation that goes through that line. We know it has a positive slope. We know it has a slope of 2. Okay, so it's something like that. So we know the slope is 2, and we know it goes through the point negative 3, negative 1. So do the same thing. Start by using point slope form. Y minus y1 equals m x minus x1. Y minus the y value, but the y value is negative, so we're going to make that plus 1, equals our slope, which is 2. And again, we get the slope from the other equation because it's telling us that they're parallel, and we know that if they're parallel, they have the same slope. And then x minus our x value, but our x value is also negative, so we're going to make that plus 3. Now this has to be an equation in slope-intercept form, so we got to write this in slope-intercept form, which means we need to solve for y. So distribute here, we have 2x plus 6, and we still have y plus 1 over on the left side. Subtract 1 from both sides to solve for y, and we have y equals 2x plus 5. Okay, so this is going to go through the y-intercept right here at 5, where this other equation has the same slope of 2, but it's going through the y-axis a little bit lower down here at 3. But they're parallel. Okay, now we got to write an equation of a perpendicular line. So it's the same exact process, but if they're perpendicular, we can't use the same slope. So here's our equation that we have, and it says, what equation in slope-intercept form represents the line that passes through this point and is perpendicular to this line? So we know the slope of this line is 1/3, but the slope of the line that we want to use is going to be the opposite reciprocal. So take the reciprocal of 1/3, flip it upside down, and it becomes 3 over 1, which is just 3. But we want to make sure it's the opposite, so since that was a positive, we need to make this a negative. So our slope that we're going to use for our new equation is going to be negative 3, and it's going to go through the point 2, 4. So you have a slope, you have a point. Use point slope form. Y minus y1 equals m x minus x1. So y minus our y value, which is 4, equals our new slope, which is negative 3, and then x minus our x value, which is 2. It says write an equation in slope-intercept form, so we have to make sure we solve this for y. So distribute, we have negative 3x, we have negative 3x, and then negative 3 times negative 2 is positive 6. We still have y minus 4 over here. Add 4 to both sides, and we have y equals negative 3x plus 10. Okay, so they definitely have different y-intercepts, and when you do perpendicular lines, the slopes aren't going to be the same. When you're done, this should be 1/3, and this should be the opposite reciprocal, which is -3. So you can always double check and make sure you did it right at the end. Okay, one more of those. So we have a line that passes through this point, 1/8, and is perpendicular to the graph of y equals 2x plus 1. What equation represents the line in slope-intercept form? So the slope in this equation is 2. So the slope we want to use for our equation, the opposite reciprocal, is going to be negative, because that's a positive. Now 2, that would really be 2 over 1. So we want to flip that upside down, and our slope is going to be 1/2. And it's going to go through the point 1/8. So we have a slope, we have a point. Use point-slope form. Y minus y1 equals mx minus x1. Y minus our y value, which is 8, equals our new slope, which is -1/2, x minus our x value, which is 1. Okay, write it in slope-intercept form. So we have y minus 8, then we have -1/2 x. When we distribute, a -1/2 times -1 is going to be plus 1/2, and then add 8 to both sides, and we're going to have y equals -1/2 x, and then 8 plus 1/2 is 8.5. Okay, so the y-intercept is 8.5, and our slope is -1/2, which is perpendicular to 2. Alright, the second part of this is classifying lines. So they're going to give you two lines, and they're going to ask you, are they parallel, perpendicular, or neither? Pretty much the lines we've been doing, most of them are going to be neither, but you need to compare the slopes. So if we don't graph this, if we just look at the slopes, the first equation, 4y equals -5x plus 12, you don't know the slope from that equation because it's not in slope-intercept form or point-slope form. So we need to write it in one of the two. It looks like if we just divided everything by 4, it would be really easy to have it solved for y, and then it would be slope-intercept form. So divide everything by 4, and we get y equals -5/4x, and then 12 divided by 4 is plus 3. Then our other equation is y equals 4/5x minus 8. Now to see if lines are parallel, perpendicular, or neither, the only thing you need to look at is the slope. So -5/4 and 4/5. They're definitely reciprocals, and one of them's negative and one of them's positive, so the slopes are negative reciprocals, so these two lines would be perpendicular. Okay, so all you need to do is make sure you figure out the slope of both. A big mistake a lot of people make is they look at that -5. But that's not the slope because that equation wasn't in slope-intercept form yet. Okay, and one more like that are the graphs of 4x minus 3y equals 9 and 3/4x plus 7, parallel, perpendicular, or neither. So 4x minus 3y equals 9 is in standard form, because you have x and y on the same side. And standard form doesn't tell you the slope. So we need to solve this for y. So if we're going to solve this for y, I'm going to box this. I'm going to subtract 4x from both sides. So I have minus 3y equals. Now I'm going to try and, you can't do 9 minus 4 because they're not the same. But I'm going to write the minus 4x piece first and then write plus 9. Just so that it looks more like slope-intercept form where you have the mx plus b. And then to solve for y, I need to divide everything by -3. So they cancel out, and I have y equals. Now, -4 divided by -3 is just a negative divided by a negative is going to become a positive. So I'm just left with 4/3x, and then 9 minus 9 divided by -3 is -3. And we're going to compare that to y equals the other equation, which is 3/4x plus 7. So the only thing you need to look at is the slopes, 4/3 and 3/4. They're not the same, so they're not parallel, and they're reciprocals, but they're not opposite reciprocals because they're both positive. So this case, this would be neither. So you have to be really careful when you solve these, because if you would have forgotten this little negative here, you wouldn't have divided by a negative, you would have divided by a positive. and then you would have got a negative answer when you solved it, and you would have wrote down, well, you would have thought that they were perpendicular because they would have been opposite reciprocal. So be very careful when you solve these equations that you keep track of your negatives. Okay, and that's it for this lesson, so just check out the lesson check on page 333, and we'll do those tomorrow.